Hello all, welcome to natural language processing. So in this session we are going to discuss about SMS spam classification problem. Okay, so in the previous session we have discussed about how to pre-process the text data for natural language processing, how to convert text to vectors, that is pre-processing, and how to apply stop words, bag of words, or count vectorization, or TF-IDF, so lemmatization, then stemming, so and so on and so forth, right? So all these techniques are required for you before you really apply any machine learning algorithm. So in this particular session we are going to discuss about how we can apply classification machine learning algorithm on the data, which is SMS data, so SMS spam data. Okay, so our objective here is to identify if the SMS is a spam SMS or not a spam SMS. Okay, the same logic can be applied on email classification, on Twitter, or on any kind of messages which you want to classify them into two categories, either of one of the categories like spam or not a spam or ham. Okay, so let's begin with one data set. So let me just do import first. Import pandas as pd, import numpy as np. Let me just increase the font. I hope this is audible. Yeah. Then import matplot. Oh, you don't need any plotting as such for now. Okay, so I will import regular expression. I will import NLTK, right? So we are going to use this library. So this is what we need as of now. As and when we need to use more libraries, we can import them, right? So for now, this is the CSV I want to get. Volumes, mac data, then SMS collection. I have one. Okay, so yeah, let me see. Oops, I see some error. Let me collect this into SMS variable name. So what I can see is error tokenizing data. See error expected 2 fields in line number 12. Okay, that is expecting 2 fields. So let me just check this data set. That's something important we have to understand. Okay, so the data is SMS collection .txt. Okay, it's a text data, understood. So it's a text data. So and there is no this data we cannot read as a CSV because this is a tab separated data, right? You see here the SMS label given here and the actual message here. Okay, and those are separated by tabs. So if you remember, if you recall, we have used read CSV only for reading the tab separated data using a separator, that is /t, right? So here you go, you can see here ham. Oops, there is again one little problem. Now what do you think what we have missed here? So the very first record is treated as a header by default. So you have an option saying you can have header equal to none. Okay, so you can try this and you will see that the very first message is no more label, no more an index here, but you can have some labels if you want, right? Header equal to none, or you will also do something called names equal to. So you can label them, right? So what is this? This is label and this is the actual SMS, right? So what you can do is you will take label here and here you can do SMS. Okay, I will just say message because I'm using SMS as a variable name here, so I'll avoid confusion. So I give a message. So the moment you do this, now you can see this is how your data set looks like. Okay, so now let's begin with the data cleaning and pre-processing steps. Okay, and here we have to do the NLTK dot download stop words if you did not download, but I assume you already have this downloaded. In the previous session we have used it, so I'm not going to download again. But if at all you're doing this for first time, so you need to download using NLTK download function. Okay, and the next step would be get the corpus, get the stop words, and get the stemmer or lemmatization if you want to use. Let's say from NLTK dot corpus import stop words. Then I have one more library, NLTK dot stem dot porter import porter stemmer. Okay, I hope you recall we have used in please, if you don't know what is stop words, what is porter stemmer, or what is stemming, so please refer to my previous video. We have discussed about tokenization, stemming, and lemmatization in one of the session. Okay, here you see we got one porter stemmer. I will create one the object for this particular class, porter stemmer, so that we will be using this for our use for applying the stemming on the words in our messages, right? So for example, now suppose for I in range here, range length of SMS. So let me just show you first length of SMS, how many messages are there, right, in this particular data set. So I have total 5572, or you can actually check using shape as well, right, 5572, and there are two columns obviously, right? It's a label and the message. So you have these many messages. So for each message I want to iterate over, right? This is very important, guys, right? I am iterating over the entire data set, and I want to work on only the one message at a time. Okay, so to make it simple, let's say print this. Okay, I break it because I just want to print a very first message, right? And if I continue printing this, I'm just printing the first message, the second message, the third message, the fourth message, and the fifth, and so on and so forth, right? So our interest is not to print these messages, but yes, we will do further, right? I have explained about a regular expression. I will use re and find out the substring. Remember that review is just a variable name. Re is a regular expression. I have imported here because I knew I'm going to use this here. And generally whenever we do natural language processing, as I mentioned in a very first session, regular expression and string operations are quite useful techniques in order to process your data, right? That is text data. So a regular expression, I will create one regex here, regular expression here. So I want to start with any character, so A to Z or A to capital Z, capital A to capital Z, right? So if I find any of these characters, so I want to give a space there, right? It's as simple as I'm just replacing any character other than alphabets. Okay, it could be a special symbol, or it could be anything, right? Special symbols are any numbers, numeric data, and anything, right? So for that we have done this, and let's say review, I want to print, and you will see what is happening. See, this is what the very first message is, and the second message, the second that review is printed, the review is not having all these punctuations like comma or a colon, or maybe dot, full stop. Okay, and every these special characters are replaced with a space. Remember, right? Here there are 3 dots, so we have 3 spaces here, 2 dots, 2 spaces here. Okay, and so on. There is 1 comma, so 1 comma, 1 space here. So that is what we have done here. So just to make you understand, so this is what we can do with the help of a regular expression and the data, right? So I will enhance this little bit here. So this is just for your understanding. Now line number 18 is just for your understanding. Now that I have this whole data. Now my purpose is to get this data stored, or somehow create the bag of word out of it. So what I can do right away is, instead of print, I will not print here, I will create review re dot sub, and I have this replacement here. So then later I will create review again. Okay, I mean, I'm not creating as such, but I'm just converting all to lowercase. Okay, and then I will also do a split. Okay, but let's wait first. I have just converted to lowercase because GOG is capital here, available A is capital here, sign, that's SC is capital here. So I don't want, right? That's what we learned in, you know, in the previous sessions, in the data, in the pre-processing part of natural language processing, where, you know, we do convert our data set for machine learning algorithm, by doing case lowering, stemming, lemmatization, stop words, noise removal, and so on and so forth, right? There are different techniques to perform to get you data pre-processed before you actually apply any machine learning algorithm, right? So I'm doing here a lowercase, so that I get this lowercase. And then if I do split again, as I said, this split and lower, these are the string functions, and re is a regular expression, right? So I hope you have revised your string operations and regular expression topics, and this will help you really understand and perform by your own, right? Basically what I have done here is I have converted your entire message, that is only one message, by, you know, splitting. Or you may go for tokenization, right? If you remember, we have used token, word tokenization for creating tokens of this of any string or a sentence or a message. Okay, so this is tokenization happens by default on the space as a boundary there. So split also does the same way, right? And hence I'm using split here. Okay, but this is not done, right? So we are still, not done with the complete processing here. We have some words, okay, where I need to find out their stem words. Okay, so we can go for a stemmer, right? So what I will do is I will find out ps dot stem on the word. Okay, now for all the words in review, so obviously review means this is the list I have, right? So in this list I'm getting each word and getting the stem of that word. Okay, stem of go is go, until and so on and so forth, right? So we have to find out if I'm getting really what I'm expected, I'm doing here, I'm expecting here, right? So you could very well see that. Okay, so the stemming also always works on the little poor way, I would say, because stemming does not give you a meaningful word, I would say, right? So crazy, this is a crazy, available, avail, right? So that is something only and only, right? You'll really find it, the difference, that it try to bring down the stem words, but it does not care about whether you are getting a meaningful word out of it or not. Okay, and hence we discuss about, we can go for lemmatization, but for SMS classification or sentiment analysis, if speed matters, then stemming works in a very fast way, right? Stemming is a quick one. Stemming has a higher performance and it works in a faster way, whereas lemmatization takes some time. Okay, usually if response matters, then we should go for lemmatization, for example in the chatbots and some of the natural language processing applications, right? So we can try lemmatization instead of stemming if you want, but for now we can perform using stemming. But yeah, we also want to ensure that these words are not in the stop words. So I mean, I want to remove the stop words as well at the same time, so right? So this, it doesn't make sense to repeat the same process again in the next command, but I will do it in the same command. If not word in stop words dot words, it's English, right? So please refer stop words video if you are still not very comfortable with the kind of code I'm writing here. So this tells you that you are going to get all the stop words in English language, and you are checking if this word is not present in the stop word, if this word is not present in the stop word, if this word is not present in this stop words, right? Then only you consider, otherwise you don't consider. So for example, in exist in this stop words list, right? So in that case it should not be considered and printed here. Okay, so let me see here. So now you can see there are few words gone automatically. For example here, so only is not available now. So after avail, only and in is no more present, because these are the stop words, right? In present, great, world, la, e, perfect, sign. There is one more such word that is called stop word, right? And that's all, right? So you may find many of such words in reality, right? So in that case, this stop word technique will help you. So that now what I will do is, instead of printing, I will keep it into a same variable and print review, right? So this makes better clarity, right? This gives you better clarity. So you have still a review, and which is having now no stop words. Okay, I hope you understand here. So now what I can do is, I will also convert back to review whatever it was having. So let's say string dot join by the spaces and the review, right? So you iterate over review. Okay, again I'm just explaining you that a review, the string function has a lot of functions. A string object has a lot of functions, string functions. You could actually use join, will join each word, which will be each element of the list. In short, here review is a list, and each element of the review is a word, and each word is getting joined by space, right? That's how join works, right? So, and you will ultimately see the same sentence again. Okay, not the same sentence, but after removing the stop words, and after converting some of the some of the words to their stems, right? So I will remove all these print statements now. So this is one print statement, this is second print statement, and the third print statement, right? Then what to do then, right? I will keep the third one, right? Because I know this is how my message looks like. Okay, the very first message. Now remember guys, we have used a stemming here, so you may try the same approach after doing lemmatization and see if you get any improvement on the overall accuracy of the model, right? And I'm sure you will find something there, right? So corpus, I will create now the corpus of all the messages. That is the list I will create, and here corpus dot append, and here I will append review. So I don't need to print it now anymore, right? I'll keep it commented though, right? Then later on, if I do corpus, and let's say first 5 messages, I will see, oh, I can't see, there is only one message. Now the question is why? Oh yeah, I got it. So I'm using break here, right? So I should have removed the break statement, so it is still processing. Look at this, right? Now it will take little time guys, right? Remember, we have 5,572 messages. Okay, and for every message we are going through each word, and we are applying the stemming on that, and then at the same time we are checking if that is not a stop word, right? So this process takes little time, right? Still it has done quite well, and I can see that for first 5 messages it has done this way, right? So there is at the same time you are actually removing any special characters as well, right? So that's why it takes a little more time. So these are first 5 messages you will see, and you will see that these 3 actions are taken place, or 3 operations have been performed on each of these messages in the data set. Okay, the first is to remove any special characters and replace them with the space. Second is convert it to lowercase. Third is stemming, apply the stemming on each of the words, and then check if that is not any of these any word in the message is not a stop word. If it is, then remove it. Okay, and then join back to the original message, right? The way original message is, the similar format we will be having, it's a single statement or a string. Okay, so that is the very first pre-processing step. Now we can do is we can actually try and apply bag of words. Okay, please refer my previous video if you are not clear about what is bag of words. Okay, bag of words model, right? In that video I have explained with the help of a example. So for that we will use feature extraction dot text. Okay, this particular submodule provides you count vectorization, right? So count vectorization is a module which we will be using, and let's say cv equal to count vectorization. I will create a model here, I mean the count vectorizer here, right? And let me check if I can use any of the message, any of the characteristics or any of the uh, parameters here. So let's say um, I have, let's say I'll go for max features, let's say, right? So you may choose to go with the default. I'll just go with the 5000 here. So that means top frequent columns, without max feature option, you can actually check how many columns you get, but yes, you can actually decide on so how many maximum features you want to consider when you apply count vectorization, right? So let's have this, once I run this, then you will you can actually use count vectorizer. Before that, let us get our x and y. So cv dot fit transform. Okay, you can do fit and transform, or fit transform does for you for once for all, right? So corpus, we give the entire corpus. Remember, our corpus is a list now, right? And this list contains all the SMSs after pre-processing, right? So the pre-processed SMSs are given here, right? You get your corpus, right, and then convert it to array, right? You remember we used to convert this to array in the bag of words session, right? Please revisit, and because the fit transform gives you a sparse matrix and we want to convert it to array, so that we can actually get your x as a numpy array, and at the same time you could actually have convert this data into a data frame as well, right? Now my interest is to get y. Okay, but remember y is a pretty straightforward variable we have, right? SMS dot label. But remember, our label is actually a categorical variable, ham or spam. Okay, ham is a legitimate message and spam is a spam message, right? So what I can do is I can actually apply get dummies. Okay, pd dot get dummies, and apply get dummies on this particular column. Okay, so that you will have let me check first what is how this looks like, right? And you can see very well that here you have your ham and spam, right? You can actually keep spam here because spam is either 0 or 1, so that should be okay. So you can actually drop your ham column here, right? So whatever you get, you can simply drop in the same uh, column, same command, and access needs to be 1, guys, remember, right? So now you see here there's a spam, right? And you can actually get your messages here. So you got your data frame here itself. You can do values and you will get no, just a minute. Oh, without the round bracket, right? You got this into the numpy array, and that's what that's what is the type of variable we expect, right? So this is how you get your x and y, right? So this is pretty much, guys, this is something very important step we achieved. So you now remember that you got your x and y from the text data after pre-processing and after applying bag of words, right? Now you may try and explore this same problem statement using TF-IDF or any other technique to work with your data to represent your words, your text data actually, right? So TF-IDF will give you better accuracy. That is what I feel, right? You can try. That is your homework for that is your homework, right? So please try with TF-IDF as well, right? So remember, there are two things to enhance this particular problem statement. One is, instead of stemmer, you go for lemmatization and check if you get more accuracy. Instead of bag of words, that is count vectorizer, you please check with TF-IDF. Okay, so to convert your text to a structured data, that is numerical, and that might help you to achieve higher accuracy, right? So these are the two additional things you may try on this particular problem statement to improve, right? For now, I will get train test split. Okay, I need to import from sklearn dot model selection, import train test split, then train test split. Yeah, here I'll go with, so I'll just copy this here, and I have X and Y already with me, right? And I'll get a 20% data for testing purpose, and I'll keep random state as any value, or you may go for 0, that's okay, right? So you already have X and Y here, right? And you have now splitted that data into 4 parts, right? Remember, please refer your machine learning basics if you don't recall how train test split works. Okay, but just to make you aware that this gives you 4 parts of your data, original data, that is your X train data, X test data, Y train data, and Y test data. Okay, now we are free to apply one of the machine learning algorithms that is comes under naive Bayes classifier. Okay, from sklearn naive Bayes, import multinomial naive Bayes, right? So you could check Bernoulli or multinomial, right? And that's okay. I mean, that is another way to hyperparameter, or you check with the different algorithms to see if you get higher accuracy, right? But naive Bayes is one of the probability based machine learning algorithm, where we have naive assumption that the features are independent to each other, and we can apply this particular algorithm to decide to predict or to train your model using the Bayes theorem concept, right? So please revisit your machine learning naive Bayes classification model, okay, in case if you want to learn more about naive Bayes, right? So let me check spam detector. Okay, spam detector equal to now we have, let's say, multinomial NB, and that's the object we have created. Now, as I said, please try Bernoulli as well. Bernoulli NB, yeah. So you may try that. Okay, for now I'm not going to use it. Now let's take spam detector dot fit. Okay, X train and Y train. Okay, these are the two data sets we have, and what you can see here, this is now getting trained with the X train and Y train data. Now your spam detector is now ready to make the predictions, guys, right? So you can see that the predictions can be done through this particular model, because this model got trained using your existing data, right? The training data, which is the X and Y. X means these are the features after converting to numbers using bag of words, and then Y train, that is your outcome, whether it is a spam or not a spam, right? And that outcome is also known, right? This is a question, this is answer, this is a message, this is whether it is a spam or not a spam, right? So now, basis on this existing data, that is the historical data, machine is now able to learn out of it, right? The spam detector is actually learned about these characteristics of these messages and the outcome, that label, right? So that now this particular object, if I ask it to predict whether a given message is spam or not a spam, it will be able to do it, right? And right now I don't take any message as such, but I will take a X train itself, right? So the training data itself, so that I will see how to get a predictions that is widespread. Okay, And you see here, if I do this wipe rate, I can see that, okay, this is how the predictions are given. Okay, and most likely, okay, these are quite close to what you actually have it in the data set, if at all you want to see it, right? So wipe rate is actually a white test, white train. Okay, and you could see here 0 0 0 first three matches, even last three matches, and in between we have to check how much it matches, right? At the same time, you can actually check this spam detector for your X test data. Okay, so that you will check this with first let me print wipe rate, and here is white test. So ideally even this should be exactly same, right? And you could see first three and last three, at least that much is matched, but you have to actually find out the percentage of with your training data and your testing data, right? For that you can check from sklearn metrics, sklearn.metrics, import accuracy score and a confusion matrix. I hope you recall this. If you don't, then this is again a part of machine learning algorithms. Please revisit machine learning topics in order to understand what is the accuracy score and confusion matrix for classification algorithms. Okay, so the accuracy score, what I can do here is for, let's say, this is going to be y test X train, so y train, I think. Okay, y train and the prediction, that is what we got here, right? So y train, and guys, you can see that 99.2%, so almost for almost for 99 times of out of 100 messages, it is making a correct prediction, right? So that's fantastic, right? So because our model got trained with the training data, so now if I do the same thing, right, with the testing data, right? So let me see how I can see, right? Why this is about why wipe rate versus y test. Okay, here also you can see, right, now this is a brand new data, guys. Machine learning model does not know about this data, right? At least the training data machine learning model knew it already, but when we have a testing data, right, this data is not exposed to machine learning model, and still this is a new data. And if I give the new data to make a prediction using a predict method here, okay, you can see the predictions are quite matching to the actual output, which is manually labeled, whether it is a ham or not a ham, or a spam or a legitimate message in your data set. Okay, and confusion matrix gives you a little more clarity about what kind of errors we see, right? And that is true positive and false positive and type 1 error and type 2 errors. Basically you can actually find it here. So out of total 1050 or 91 plus 2000, almost 2015 messages, right? So I'm just taking some approximation here. So if you add, you'll perhaps find this. So okay, how many? Okay, 1115 messages, right? So out of 1115 messages, there are 16 and 8. These are the false predictions you see, right? And that's why we get 97.8%, quite a good accuracy, guys, right? So it is a nice accuracy, we can see, right? And our model is now able to identify the spam emails, spam SMS here, right? So the same technique can be used for identifying the email, text, or any other text for that matter, right? So this is how a very simple example, but quite useful, right? You can actually apply on many use cases in the practical scenario, right? And understand how we can process. So this particular exercise is meant to have the end-to-end solution for any natural language processing, right from reading the data, processing the data, cleaning the data, right? And definitely for cleaning and processing and collecting data, you may use different Python modules, like web scraping or getting data from different sources, or maybe XML parsing, right, or HTML parsing, or JSON parsing, right? And then data cleaning, where you will have to remove noise, remove unnecessary tags, then do change or convert your data into lowercase text data. Then you can probably remove the stop words, then you can probably apply stemming, limitization, right? And then bag of words or TF-IDF. So ultimate goal here is to convert your text into vectors, and that vectors you can actually give it to any machine learning algorithm. So naive Bayes classifier is what I have used here. You may try logistic regression, or support vector machine, and or try any other algorithm and observe. So naive Bayes works better in such examples, because it works on probability, and you will find the closest possible outcome for detecting whether it is a spam message or not a spam message, right? So then we can train our model here, and then this model can will start predicting the outcome for you. Okay, and you have accuracy score, confusion matrix to check how well your model is doing, and you can actually have the overall accuracy and check with the business if you are achieving or if you are meeting your business objective. Okay, and that's pretty simple, and that's very exciting, guys. Very simple one, but yes, this can take you to solve so many problems in the similar space. Okay, so this is what I had for spam detector or SMS spam classifier machine learning model on natural language processing. Okay, thanks for watching. See you in the next video. Thank you.